NASA's first crewed lunar landing is now officially no earlier than 2028. China's uncrewed lunar rehearsal is targeting 2028-2029, and its crewed landing target is 2030. Two different programs are now compressed into the same window. Only one of them is tested its moon rocket on February 11th. That test now puts real pressure on NASA's lunar timeline. On February 11, 2026, China carried out the first ignition flight of the Long March 10A prototype at Wenchang in Hainan. This was not a full lunar launch, it was a low-altitude demonstration flight built around a Max-Q abort test for the new Mengzhou crew capsule, plus recovery-related testing for the booster. The capsule splashed down successfully later that day. The rocket reached about 105 kilometers, a height chosen to match the shutdown conditions expected for the first stage in actual missions, so engineers could gather realistic flight data instead of just theory or ground test numbers. What matters technically is not just that the rocket flew, it is what China chose to test in one shot. The program tested ascent loads during the most stressful part of flight, capsule escape under those conditions, engine performance from a 7-engine first stage, and return phase and recovery-related systems on the booster. One grid fin reportedly failed to deploy during the recovery profile, but the vehicle still completed the overall test sequence, which tells you something important. This is still an active test program, not an operational launch system yet. That distinction matters because the Long March 10A that flew on February 11th is not the full lunar rocket that China needs for a crewed moon mission. The prototype was a single-core version. It had no upper stage, no lunar payload, and no orbital mission profile. The full lunar version adds 2 strap-on boosters and a hydrogen-fueled third stage, and it must deliver at least 27 tons to translunar injection. That is the point where the mission stops being a test of components and becomes a real lunar transport system. And that capability has not yet been demonstrated in flight. The single assumption that has to be true for China's optimistic scenario to work is this: the full Long March 10 lunar stack must fly successfully, deliver 27 tons to translunar injection, and do it soon enough to leave time for an uncrewed dress rehearsal before the crewed landing phase. That is the core constraint. Everything else hangs off of it. Here is the sequence that China still has to prove. First, the complete lunar configuration has to fly, not just the single-core prototype. Second, the hydrogen-fueled third stage must perform in the actual mission profile required for lunar transfer. Third, the system must demonstrate it can accelerate the required mass toward the moon. Fourth, China has to integrate 2 launches into a single lunar mission architecture. One Long March 10 carrying the Mengzhou spacecraft and another carrying the Lanyu lunar lander stack. Then those vehicles have to rendezvous precisely in lunar orbit. China does have a real foundation here. Chang'e 5 completed automated rendezvous and docking in lunar orbit in 2020, but that was with robotic hardware, not with a full crewed lunar stack at this scale. So the engineering challenge is not vague, it is very specific. China has now shown progress in first stage flight behavior, abort testing, engine performance, and flight dynamics, along with some recovery technologies. It has not yet shown the full stack lunar launcher, the complete transfer profile, or a crew-capable lunar mission chain. The test on February 11th reduced uncertainty around one part of the architecture. It did not remove uncertainty from the whole architecture. That is why the pressure exists in the first place. What if the full Long March 10 stack slips past 2027? Then the 2028-2029 window for an uncrewed Mengzhou Lanyu rehearsal gets tight very quickly. China would need the maiden flight of the complete lunar launcher, enough confidence in the integrated system to fly the full mission chain, and then enough time to process the data and clear the crewed architecture. No catastrophe is required here. The calendar alone does the damage. One lost year compresses everything that follows. What if the constraint fails more quietly than that? Maybe the first full stack flight works, but the third stage underperforms. Maybe the integration is fine, but the schedule leaves too little time between the first complete launch and the uncrewed lunar rehearsal. Maybe the LANU lander continues to pass Earth base landing and liftoff tests, but lunar surface performance still needs more confidence. Those are not dramatic failures, they are ordinary program risks. But when the target window is 2028-2029 for rehearsal and 2030 for landing, ordinary risk quickly becomes schedule pressure. Now add the institutional layer. NASA's timeline is under pressure too, but for different reasons. On February 27, 2026, NASA announced a major restructuring of the Artemis program. Artemis 3 is now planned as a 2027 low Earth orbit test mission focused on docking and systems checkout with commercial landers. The first crewed lunar landing has moved to Artemis 4 in 2028. NASA made that change because too many critical technologies were piling up on a single mission. In other words, NASA reviewed its schedule and concluded it needed another test step before attempting the landing. NASA, by design, does not move in a vacuum. Budget, contract, and mission changes all move through institutional processes that take time. China's program can make faster internal decisions and move more directly. NASA has to work through Congress, industry partners, and formal architecture changes. That does not automatically make one system better, but it does mean that the schedule compression hits the two programs differently. China's pressure is mostly engineering and calendar. NASA's pressure is engineering, calendar, and approval cycles all at once. The strategic context matters here. China's dated milestone is clear: February 11, 2026, first ignition flight of Long March 10A, with a successful Max-Q abort test for Meng Zhao and a realistic first-stage flight profile to 105 kilometers. NASA's dated milestone is now clear: February 27, 2026, Artemis architecture was reshaped, with Artemis 3 turned into a low Earth orbit precursor test, and the first crewed landing moved to Artemis 4 in 2028. Both programs are still moving, but they are moving in different ways. China's architecture concentrates risk in full-stack integration. It avoids orbital refueling entirely. 2 launches, lunar orbit rendezvous, surface transfer, return. The recent Long March 10A test expands something real that China has already shown in pieces: booster flight behavior, capsule abort, engine performance, and previously robotic lunar orbit rendezvous during Chang'e 5. Its main unanswered question is whether the complete lunar stack can come together on time and at full mission scale. NASA's architecture concentrates risk somewhere else. SLS and Orion still have to keep moving after recent launch processing issues. Orion's heat shield path has drawn scrutiny, and the Starship human landing system still depends on orbital refueling and full HLS certification, neither of which is complete. NASA's new architecture adds a mission step before landing. That is a rational response, but the key demonstrations are still ahead. Here is the contrast in plain language. China is expanding its demonstrated capability, but still has to prove the full lunar stack. NASA is preserving a landing window, but still has to prove the systems that make the landing architecture possible. One program is managing known integration risk. The other is managing a broader stack of certification and mission architecture risk. The contrast is architectural, not ideological. And that is exactly why China's February test increases pressure on NASA without proving that China is already ready. China's February 11th test did not prove a crewed lunar system, but it did move one part of that system from paper into flight. And it did so while NASA was redesigning Artemis to protect a landing target that now sits in the same late decade window. If China reaches its uncrewed rehearsal in 2028-2029, and NASA still has not cleared its own landing architecture, what decision does NASA have to make, and how quickly would they have to make it?